let me do this here. So class, we have 4.4 up today. You can turn in homework 4.3 either today or Wednesday, whichever one. We did talk about presentations before Thanksgiving break. So if you are ready for your presentation, just email it to me or just say you're going to present it, because you have one of two ways to submit it, either by Google Slides, which is probably easier, preferred. I get it. I click on it and we're good to go. But if you want to submit it on a thumb drive and you have it in PowerPoint, then bring your thumb drive, just email me ahead of time. I want to present on the 14th. That's cool. Okay, and I'll sort of be ready for that. And so if you are going to do that, maybe during announcements, if you can give me the thumb drive, I'll set it up so that we're ready to go at the beginning period. So the schedule is written right over here. So I do have verbal final, at least the beginning parts of verbal final. Let's see how much we get through on the 21st. We a slight review or review questions if we have any on the 21st. And I do have your written final set for the 24th. I will give you guys study guides today or tomorrow. I should guys give you study guides for it. And then the 26th will be anything that's sort of left over for that, for the end of school here. So end of semester. Okay, any questions on that? Okay, and then please ask me questions on Wednesday if you forget or something like that, right? Just kind of keep on asking me the questions, just to make sure it's clear in your mind, because I hate for you guys to be sort of off on something. It should be clear. Okay, let's jam. So a quick review was requested of. So 4.1, yeah, I remember 4.1. We spent a long time on 4.1. We talked about graphs. We talked about going from, so just a quick review, going from the unit circle, right? This little guy right here, which we have been doing trigonometry on this little thing for a long time. And we finally graduated so that we're actually on an X and Y plane. And we did that for sine. We also did that for cosine. So the major graphs for sine, as we think about it, is this right here. That's a sine graph. And we think about this is pi, this is 2 pi, this is 3 pi over 2, and this is pi over 2. And we have these critical points, 0, 0, pi over 2, 1, and then the rest of them for sine. And we graph based upon these guys. Then we also did cosine. Cosine does a hill, valley, hill. So it starts off at 0, 1. And again, here's your important pieces there. This is 2 pi, that's pi, 3 pi over 2, and pi over 2. Okay, and then we graphed everything based upon that. Are we good there with those guys? And that took a little while, right, for us to sort of see it. And then 4.2 started off this whole concept of amplitude. Amplitude is the middle of it to the height, or the middle of it to the bottom. So it's half of the full height of it here. Then we talked about reflection. And reflection about the x-axis. We can do that. We can reflect it about the x-axis. And then we also
just how high it goes, right? Or
how high it goes from the middle.
The period is how long it takes it to do one revolution.
Perfect. Yeah.
And it's also the absolute value of the A value, right?
Mm-hmm.
Which is just the variable in front of cosine sine.
Mm-hmm.
Oh no, I don't remember.
Oh yeah.
Okay, so let's bring in the so this is A sine of bx plus c plus d, something like along those lines. Is that the way we did it? Now I remember writing it slightly different here on the board here. So let me jump to that one just to make sure the translations here. Okay, it's H. Okay, yeah, let me write it the way the book did it. It's gonna be B. It was like this. There's a parenthesis. It was a B, and then it was X minus H plus K. Do you guys remember that formula?
You have to take the B out, or it's already taken out now.
Yeah, you had to factor out the B out, and when you did that, you were good because that was your phase shift right here. Phase shift was to the right or the left. You already knew what your phase shift was right away. That's your vertical shift, VS for vertical shift. And almost, the period was,
It's the.
the period for sine and cosine was 2 pi over b. For tangent is gonna be pi over b. So there's tangent, it cycles every half a circle. So it has a little formula. And so based upon these guys here, based upon period, based upon that one, and then the reflection just means you have a negative in front of a. That still came out from over there. Okay, does that get your math juices flowing? Is that right? You guys remember that kind of stuff?
Are we ever going to be back in the tangent?
Yippity-doo-dah.
We do like one
yippity-doo.
warm-up problem before we go to 4.4.
Oh, yeah, that'd be cool.
To make them 4.4.
Yeah, graphing.
We do, or I think one, but I actually would must, gonna be like 1.4.3 that encompasses all of
Mm-hmm.
Yeah, graphing something with a sign is up to the best.
Mm-hmm. So are we good there? And so 4.3, just one problem here. 4.3.
that. I think 41 is a good example. I don't remember how I did that.
41, I'll go with 41. That's right, you guys should have your homework out, right? Because you, if you want to turn in today or you turn in Wednesday here, here's our problem right here. Compasses should encompass everything that we've done so far.
Well, I hate the ones that are pi over 3.
Shucks, that's why I gave it to you. Or it's because Dylan said so too, so you can blame it on Dylan.
We're gonna beat you up in the parking lot.
So I personally like to write the -2 at the end, because remember, that's the way we do it with polynomials and all that stuff, right? Just me. So got that guy. I got 3 cosine, and then if you want to do brackets here, I mean, other textbooks do brackets because it kind of allows you to see the difference between the parentheses and stuff, but that 1/2 has to get out of here. And now the question is this: what multiplies 1/2 to get a 1/3 inside there?
Yeah, it's not the end of it. How do we know that the 3 is the one that has to go next to the cosine, not with the -2?
Because it's multiplying the right in the beginning. It's right next to the cosine, as opposed to this guy has a little plus sign that's ready. Just situates, makes it go out. All right, let's see. Just waiting here. Let's see what multiplies 1/2 so that at the end I get a pi over 3.
Pi over 6. No.
Did we factor out the 1/2 just so we got
Oh.
X on the spell?
We factored out the 1/2 in order to have a capital B. We know what capital B is.
Oh, yeah, because we need the variable on the outside.
3.
Yeah, we need the multiplier to the X and the phase shift.
2 pi over 3.
2 pi over 3. I think I like that. Everybody agree with 2 pi over 3. Close off that whole thing, and then we put a -2. Okay, I think I have everything I need here. So start off here. Amplitude is going to be 3. Reflection. No reflection because the negative is not. And my period. It's going to be 2 pi divided by 1/2, which would be just 2 pi times 2, or 4 pi. I'm going out to 4 pi on this guy. What do you guys say? So far, so good? Okay, I think I can do my first set here. So I got a phase shift of what? 2 pi over 3 to the
It's right.
right. Yeah, because it's always opposite.
Reverse for the normal
I got a vertical shift of 2 down. Okay, boom. There's all my different things that I need to do with it here. So boom. Hopefully, as soon as you write that down, I'm going to start process here. 4 pi, 2 pi over 3. Man, this does not look very nice. Like,
Then it's 4 pi and 2 pi, you're only gonna get half of the full rotation.
it says graph 1 complete cycle. So we're going to determine our graph paper. So we go here. We'll go to 4 pi, but we know we're going to have a we know we're going to also have a phase shift on our hands, right? And that phase shift is 2 pi over 3. So I'm thinking to myself, you know, that phase shift is almost another pi. Is that right? So I'm going to go out all the way to 5 pi here. That's going to be 2 pi, 3 pi, that's pi. So, whoa, 1, 2, 3, that looks really exaggerated out here. So that's more like 5 pi here. Okay, it's cosine. Let's see if I can do the very initial one. And I know it's 3. Oh, remember we did max and min, right? We did the highest value this guy can go and the lowest value this guy can go.
Amplitude's 3, so it just goes. But then there's the vertical shift of down 2, so it's 1 and negative 5.
Highest it goes 3, lowest it goes -3. So it's going to go down here. 1, 2, 3, 4, 5, 6. So we can do it like that. Okay, initial target is here it is, my initial graph. Just putting in these pieces right here before I do the phase shift and the downshift, right? Before I do the shifting over. If you can do it all in one spot, all in one way, that's perfect too, right? If you need the breakup, usually the breakup is right here. So no reflection, amplitude 3, period is 4. So I got myself boom, 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 and boom. There's my initial dots for cosine. I'm going to go down 2 units and I'm going to go to the right about 2/3 of a pi. So that's what I'm going to do there. I'm going to change my pen color here. So I'm going to go 1, 2 and over about 2/3 of a pi. 1, 2 and over 2/3 of a pi. 1, 2, 1, 2. Okay, so I got myself a graph that does something like that. Okay, good there.
So is that good? We don't need to label everything in between.
Sorry. Yeah, you don't need to, because by the time I look at it on a test, right, I'll see what the dimensions are. Usually the graphs are way off or they're good.
Oh, that was a good reflection.
Like for the pi over 3, that helps me is for this, since it's 2 pi over 3, and I know that half a pi away is where a regular cosine thing would like go down. I just do that, but then since it's a period, we'll multiply that by 2, and then I just apparently my e-small does, which just resets it at 0 and then relabels it. That's what I find.
Yeah.
The pi over 3, so that way I don't have to actually label it. I just know that with cosine, it It should go down at the equivalent of the halfway mark. And just reset it at 0.
Uh-huh. Yeah, that's another way to do it. Absolutely. And shift over the scale then as opposed to the graph. Uh-huh. Yeah. Totally cool. Totally good to do it. Okay, 4.4. Now let's jam. So that was cosine and sine, and 4.4. Guess what? It's going to be the other trig functions.
No.
Now let's put the whole family together. So sine and cosine, we've done all that. So 4.3 took a whole section just to do sine and cosine, right, by themselves. So now let's introduce the others. Now, tangent and cotangent has to be sort of separated out just for a little bit.
So we're
But
just
then-
doing secant and cosine right now.
No, we'll do tangent, cotangent first.
Oh.
We'll do those, and then we'll jam with the other ones here. So first things first is so tangent and whoa. Tangent and cotangent. Here's the only little thing, or the only change to this is period. Actually, we should do this here. Changes. There's no amplitude
Oh, yay. Wait,
because for cosine and cotangent and cotangent, there's not a wave that we have, right? It doesn't do waves. Okay. Next,
Oh, yeah, it just does.
it just goes straight up, right? I mean, it goes up and then breaks and then goes down. It starts. So the period is not 2 pi because tangent cycles and cotangent cycles every 180 degrees as opposed to 360 degrees. So the formula for period is pi over b. Phase shift is still the same, vertical shift still the same, and then no max value and no min value. Okay, we're good there. So let's go with exercise 1. We'll start off pretty easy here. I got 3 tangent of x plus pi over 4.
Wait, but if there's no amplitude, then what is the three?
Oh.
Huh.
What's that again?
Shucks-a-roo.
It's the thing you do with the other, some algebra two that it stretches out.
Oh, yes, it's only a vertical stretch. Yeah, so even though
Darn it.
still got you in the back end, right? Like, oh no. Okay, so let's jam with it here. So I got this right here. Let's make our graph sheet of paper. Whoa, that was an interesting graph sheet of paper. Okay, let's move on to the next slide.
I feel like these are gonna be really annoying to graph.
Uh-huh. So don't even need to do amplitude, but our period though, we got to do. Period is pi over b, which is 1, just pi. That's cool. Okay. We have ourselves a phase shift of pi over 4 to the, I'm gonna go left, is that right? Vertical stretch none, and here it is. How about this? I'm gonna put a v, sorry, vertical shift, sorry, shift none. Stretch 3. So now I have to do abbreviations here. So vertical shift versus vertical stretch
Where is the vertical stretch?
The 3.
from that 3 there.
So instead of amplitude, it's vertical stretch.
Yeah, even though technically graph wise, it's still the same, right? But whenever we talk about amplitude, we're always talking about something that oscillates up and down. That's when we talk about amplitude.
So it's just the same word, it's in the same sense we were stretching it. Cosine, sine.
Correct.
function.
Uh-huh.
It's just a different word. So will there ever be a vertical stretch for these though?
For a tangent and cotangent, yeah, vertical stretch. That's what we say. It's just a vertical
I mean,
stretch.
so will there ever be a vertical shift?
Yes, we can do vertical shifts for tangent, absolutely.
Oh, wait,
That
no,
would
no,
be-
I
yeah,
did
yeah.
it. I was thinking something else.
Okay, no problem. Okay, so with these guys, we got to be mindful of, with tangent particularly, we got to be mindful of where the breaks are in our graphs. And in fact, once you know where your breaks are, you're good to go. So real quick here, let's go back. Where do we have breaks in our initial? So maybe down here, we just do like this. Where are the breaks going to occur? Let's go back to the original tangent. I know it's been a while. Let's go back to the original tangent curve. Now the one we did not draw from last time here. We have at pi over 2, right? 90 degrees and negative pi over 2. We have, there's your one cycle of tangent. We're good. So for tangent and cotangent, it almost is better just to figure out where your breaks are at, and then you can graph the function. So if we have a vertical shift of pi over 4 to the left, you guys tell me where are my vertical asymptotes?
I will go for. And, okay. You find it different? Negative?
Go to the left, so it'd be
Yeah, I know that.
Very good. So let me see what Isabel's saying here. So negative pi over 2, send these negative 2 pi over 4. We're going to go backwards on that one, right? So negative 3 pi over 4 is perfect. We shifted over from this one here. Okay, pi over 2, same thing as 2 pi over 4, and we're going to shift this guy to the left. So tell me if you guys are okay with pi over 4. Okay, we're good there. Once you get that, the rest is good. Tristan, are we good with that? Just that little piece there.
Just the graph on the bottom one, that's just a tangent graph, right?
Yeah, basic
Okay.
tangent graph.
Okay, and then we're just doing, we're just replacing them by moving the pi over 4 to the left. Okay.
So that's done. Period did not shift at all, so that's nice. There's no multiplication of the period. We'll see how that functions if we did have it.
vertical stretch.
We do have a vertical stretch of 3. We'll do that at the end here, but what we want to concentrate on, since there's no vertical shift, I want to concentrate on the 0 now. Where's the 0 located at?
Negative.
Pi over 4.
Perfect. It's right there. Negative pi over 4. I got myself a 0. Good there.
And do you want us to draw the dotted line for the vertical asymptote?
Oh yeah. So draw the dotted lines go down. Okay, I did not include some specific thing over here on my graph for my tangent originally here. So let me erase this and include it now. Whoa. There. That's what I wanted. Okay, here at pi over 4, halfway between the 0 marker and my vertical asymptote, I have my value of pi over 4 comma 1. And then over here at negative pi over 4, I got myself my negative 1. So the halfway point between those two values here. So what is a halfway point between a negative pi over 4 and a positive pi over 4? 0. And now instead of going up to 1, we're going to go up to 3. There it is. There's my tangent graph. We're good.
That's
Again.
what vertical stretch is.
So tangent graphs, cotangent graphs, they are graphed differently from sine and cosine. Okay, the halfway point between negative 3 pi over 4 and negative pi over 4. Negative 2 pi over 4. And we have ourselves this guy going down like this. Okay, so how does this graph look like? Bring it all the way across right here, right next to the vertical asymptote as it's coming up. And start curving it just a little bit here towards this side right here. Curve it, and then start curving it the other way afterwards here. So, and then get it close to the other.
Is what you did, like, instead of, since it's a stretch of 3, where from negative pi over 4, like at the 0, it would have been just 1 up to, like, it would have been 1, 0 for the next point, right? Like when if we're going in the positive direction, without a stretch, it would have been 1, 0, right? So then with the stretch, you just multiply that by 3.
Yeah.
Okay, and that's literally, and you just do that both ways.
Yeah. And so you go down 3.
Okay, so then the basic tangent graph is just basically kind of like a linear line, just stretched both ways in general.
The tangent graph, there's curves in it. The tangent
Well,
graph,
like
so
it's
like
like
it's
a
curved.
linear line, but each side is curved like that way.
Okay, we're good there. Let's jam with. Let's see if I want to include that little guy. Oh, that's 4, 3. Okay, yeah, we have to work with the negative inside there still. Okay, so let's jam with this one then. Exercise 2 or example 2. Graph for me 1/2 cotangent of negative 2x. Minutes left. I think we are headed okay. We do one of those. Okay. Okay, so cotangent, kind of think back to cotangent, maybe the best way to do it here. So the cotangent graph has a break at 0 and has a break at pi. Those are my little breakers. It goes through the 0 at pi over 2, and it starts high, comes across like this, and we do put in the ones here. So at pi over 4, it's a 1. At 3 pi over 4, it's a -1. There's my basic cotangent graph. We good?
If the period doesn't change at all, do we need to, since that's staying on top of the period, do we need to draw the other, like the duplicate of it on the side?
No, just one cycle. Yeah. Now the homework, you will tell you, most of the time it says graph 1 complete cycle. Of it, I'm just checking here.
So the period just pi for 2.
Yeah, graph 1 complete cycle, yeah. Go ahead. Sorry, I was answering Isabel's question.
I was saying the period is just pi over 2.
We got to deal with the little negative inside there though. What do we do with the negative inside there? I will tell you, cotangent is an odd function. Odd function. If it's an even. If it's an even function, we can just drop the negative. If it's an odd function, we have to. That's okay. That's why we're here. We'll put it somewhere else. In the front. Shift it to the front. So in order to get rid of a negative inside the trig function, if it's an odd function, we put the negative in front. Okay, let's go with it here. So got that on my hands and ooh, I have a reflection now, right? We got to think about the reflection. Reflection, yes. Let me go back in my, what do we do? Period. Yeah, period went first. Period is pi divided by 2 this time. Phase shift, 0, that's good. Vertical shift. And also 0, yeah, let me just check something out real quickly here.
Verticals.
I put ST for stretch, is that okay? Vertical stretch. There's 1/2, we good? See again? Oh yeah, we take care of the negative by that guy. There's my, and so notice all the different pieces we have here. So that one, that one, that one. So we have ourselves a cotangent graph for the reflection with a period of pi over 2 and with a vertical stretch of 1/2. So really it's a compression, yeah, more of a compression. Okay, so first things first, I got to figure out where my vertical asymptotes are.
Okay, sorry, so the tangent graph, the 0 is at 0, 0, but then for the cotangent, the 0 is halfway in between. Like, it starts at 0 and goes to pi, but then tangent starts at negative pi over 2 and goes to pi.
Mhm. So for cotangent, nice, the fact that our vertical asymptote starts off at 0.
There's no phase shift.
No phase shift. So therefore this pi over here, this period now is going to be just pi over 2 over here. Are we good there? There's my, I cut it in half, right? Even though my graph is bigger. So that means this guy is pi over 4. And that means if I break this up into 4 pieces, right? This is pi over 8. 2 pi over 8 will 3 pi over 8. And 4 pi over 8 is going to be pi over 2. Okay, got that. Let's see. Phase shift taken care of. Ding, ding. Reflection, I'll take care of that just a little bit here, but I almost have to do these at the same time, right? So my 0, 0 marker is going to be right here. So pi over 4, are we okay with that one? And I'm going to add in my vertical asymptotes along with my y-axis here real quick. Boom. So 1, 2. So then I'm going to go like this here. I'm going to go 1/8. It's a reflection. So then I'm down. Tell me if you guys agree. I'm down to right here. Is that right? And then I'm up to right here. So I reflected, I did the dots, right? I did my vertical compression technically. And then I almost made sure that it's reflected as well. So I think I'm good. So I'm gonna go climb up this way here. Turn. Hey, this looks like a tangent curve. With that little reflection. Okay, 15 minutes left. Okay, are we good there? Comfortable now a bit here? I think also because it was new as well, maybe after kind of getting a little bit.
This is more like slightly more complicated version of the XT graph.
Interesting. Okay. Okay. Let's see. Do 3 here. 3. Let's go back to tangent. I think we have time. Yeah, we have time for tangent here. So this one, and if you want to keep up. Okay, now the big thing here. All yours there. Whew.
Oh, that's not hard, never mind.
Problem for really satisfying if you got the right issues like the
Mhm.
Oh, yeah, you get every little piece right.
Uh-huh. Totally satisfied. It's like in algebra when you got to the answer x equals 2 and then you're like, yeah, it is x equals 2.
You
Okay.
get like one thing wrong and everything. And then the graph gets to redraw the whole thing.
All right, I'm going to pull out the 1/2. Is that okay? So the question is, what multiplies a 1/2 to give you a pi over 8? Pi over 4. Awesome. I go with that. Close off that guy. Plus 3 on the outside. I think I got whatever I need. So we don't do amplitude. Nope. Is there a reflection? Nope. What's my period?
2 pi.
Ooh,
Pi over 1/2, right?
pi over 1/2. Which is pi times 2 over 1, which is 2 pi. We have 2 pi in our hands this time. Phase shift
Pi.
to the left it is. Vertical shift 3 and vertical stretch.
Is
2. Awesome. Okay, based upon that information, can we graph this guy? So kind of careful, especially with the vertical shift now. It's not going to be as fun. You could probably do that last. Vertical shift would go last.
period.
Also, if you notice that just depending which way you want to go about graphing it, sometimes the back of the book graphs will look a little different because they'll shift, they'll do a scale shift sometimes, and they'll do a graph shift. So as long as your graph still matches up with theirs, that's fine. They don't have to be exactly the same cycle.
The scale shifting is actually a lot easier than graph shifting. Like the numbers on the sides instead of where your graph is. Would you accept either of those as an answer? On
Yeah.
this?
Absolutely. Okay, so I'm going to go here. I'm going to go here. Let's see. First things first is period is 2 pi. So notice real quick here, we got a period change, right? So originally, we're going to go from negative pi over 2 to pi over 2, right? For one value. We good? Now what we're going to do, we're going to go from negative pi to pi. We're good initially. And then we're going to shift pi over 4. That's a little bit too far. Sorry, guys. A little too far out with all my stuff that's there. So you guys talk to me here, see if this makes sense. That is a period of 2 pi, true? 2 pi for what's pi from one side, and pi to the other. We're going to shift it over pi over 4 to the left. So now this guy is negative 5 pi over 4. This guy is 3 pi over 4. Talk to me, see if you guys make good. And I'm going to erase that. And this is where my markers are at.
So do we have to mark
Base.
those? Because I just did the 2 pi to 2 pi to negative 2 pi from the pi and negative pi. And then I just drew my dotted line zeros, pi to 4 over. Is that okay?
Let me see.
So actually, I did it the wrong way. Like, do I have to mark? I know, but can I just do the dotted line and draw line?
Yeah, because you didn't go half, right? So you have pi here, negative 2 pi. So you went a little bit too much over. Right, because you shifted over a half a pi as opposed to a quarter of a pi. Okay, I got that. Okay, so that means the middle has to be pi over 4 over here. That's my middle. Okay, what else do I have here? Period I got taken care of. Phase shift we got taken care of. So vertical stretch and vertical shift. So here, it's gonna go backwards, tangent graph in my mind, goes like this, without a reflection. So initially, I would go down 1, 2. Here would be my first dot if there was no shift. And what is that point anyways? What's in between negative 5 pi over 4? Adding those up. Is it pi over 2? What's in between a negative 5 pi over 4 and a negative pi over 4? Over 2, right? Or no, or negative 3. Negative 3 pi over 4. Okay, gotcha. Yeah. Negative 3 pi over 4. And vertical stretch is here. And then let's see, between negative pi over 4 and 3 pi over 4, it'd be pi over 2. You guys talk to me here. What's this little guy right here? What's the middle between those two?
Are you talking about between negative pi over 4 and 3 pi over 4?
Yeah,
Pi over 4, positive.
Yeah.
pi over 4 positive. Yes, And that would be up by 2. Okay, I got this one. Now I'm ready for the shift here. So I'm going to move all of this up 3 units. 1, 2, 3. So this guy goes up to here. This guy right here goes up 1, 2, 3 up to here. And 1, 2, 3 up to here. And now I'm graphing across here. Here's tangent curve coming across the first point, second point, third point.
Isn't it a vertical stretch of 2?
I did the vertical stretch of 2 by going
Oh, yeah.
2 units here. Oh, you're right here. I didn't do it here though. 1, 2, 3. There you go. I forgot it on this side here. So there. There it goes. What do you guys say? Crazy?
A lot of information to into.
All at once, right? In order to be like, so like the last piece there. Okay.
We do another one of them?
I'm gonna let you guys do that for homework here, just because we got to do the secant cosecant thing. Those are gonna be easier because we want to take the extra time here. It's okay. Boom. Oh, come on. The wrong way. Computer not cooperating here. Go this way. Or my fingers are cold. Doesn't even register the fact that I'm touching. There it is. Okay, what are we on for? Okay, one last one here. This one right here. This should be okay. Is that the one I want to do? Let's see. Yeah. Okay. Yeah, we'll take the time to do that one. Okay, a little bit more complicated because you guys know how to do sine and cosine already here. You know what? Let's take off. We could do a vertical stretch afterward. We know how to do that. Let's just do the basic tough stuff. Okay. Cosecant function on our hands. Hoo-wee.
Upside down sine, right?
So here's what we're going to do. We're going to graph. It's a cosecant function. And some textbooks actually make you memorize all 6 graphs and make you memorize what is cosecant function. Your graph, your book pretty much says memorize sine, cosine, tangent, cotangent. Memorize 4 because these other 2 you build off of sine and cosine. So what we are going to graph, we're going to graph this one. And then we'll build a cosecant graph off of that. So first things first is we need to pull out pi over 2. And you guys talk to me. What multiplies pi over 2 to give me 3 pi over 4?
It'll be 3 halves.
Is it 3 halves?
I think so.
Mhm.
3, 5, yeah.
Just multiply it back in and you'll see it here. Yeah, that's cool. 3 halves. Cool. Okay. So we have amplitude 3. Reflection, yes. Period 2 pi divided by pi over 2. I think I got myself a 4. Is that right?
Yeah.
Interval of 4 seconds, 4 units, 4 milliseconds, 4 years, whatever it is there. I got myself a phase shift, I think, of negative or 3 halves to the left.
Yeah.
A vertical shift, nope. And amplitude was taken care of by the vertical stretch. Okay, can we do that? At least can we put this together and we'll do the shifting over. So I have a sine curve, technically, that has a reflection, amplitude 3, and has a period of 4. That should be easy enough here. 1, 2, 3, 4. There's that. 1, 2, 3. 1, 2, 3. It's a sine curve, so I go here, 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 here. There's my little dots. Boom. There's my sine curve.
Yeah.
Say again. You should stick with sine. Yep. And we're going to go backwards 1.5 units. So I'm going to go back. This little 0, 0 dot is going to go back to this dot here. I'm going to make these guys bigger. This dot's going to go back 1.5 to here. This dot 1.5 back to here. 1.5 back to here. And 1.5 back to here. Okay. Now your book actually draws the sine curve into it here. If we want to, just kind of dashed line, maybe it would be best to do a dashed line. Because we've got to see which direction things are going. There. Okay, cool. I'm gonna make my cosecant curve right out of that right there. So anytime you hit a 0, my cosecant curve is hitting a dashed line. So any zeros change into vertical asymptotes for my cosecant curve. All right, anything below the x-axis obviously is going to come from the negative side. It's going to come up to here and going to go like this, and it's going to peel off to do that right there. Anything that hits a positive 1 is going to come back here, hit the positive 1 or positive 3, whatever values are, and it hits that right there. Done.
Do we always have to draw a sine curve first, or can we just draw a cosine?
You can draw cosecant if you like. I mean, as long as you know where the dots are and stuff like that, but you're going to get the dots from your sine curve.
Yes, we just draw the dots in the sine curve. And then...
Yeah, that's the way your book presents it. That's the way it does it. Other textbooks makes you memorize what is a cosecant curve, like we did cotangent, tangent, right? You like we did all the rest of them. You know what it looks like. You know it goes up and down, and then you start shifting it over. You start expanding it. You do it that way. But your book does it based upon the previous 2. All right, guys. With that, we are done for the day.
Oh,
There it is. So. we have 4.5 is going to be, oh, it's going to go backwards. So 4.5 is, I give you a graph, you find me the equation.
Oh, no.
It's the backwards way.
No, that actually sounds
So
good.
this is what our final.
A good portion of our final. And then also then, ooh, 4.6 is graphing combination of functions.
Excuse me?
Uh-huh.
Oh, boy.
And then 4.7
That's
is
gonna be-
doing something called the inverse function. So with that, we'll end.
How much of our grade is the original?